Okay, good morning. I will review. This is the last session. I will talk about systems. So that the last thing we talked about last time was about geometrical way of looking at a system. So geometrically, if you want to look at a system, it means that you need to draw the graph of this function, of this equation and that equation, and look at for intersection points. But for these systems, it is very simple because you know from Math 1C that any equation of this form, when being graphed on GeoGebra, for example, it will provide you with a straight line. And this will also do the same thing. So here, this is a straight line and that's a straight line. When I want to solve the system, it means that I am looking for the intersection points of two lines. So there are three possibilities for two lines on the plane, yes? Either the lines intersect exactly at one point. In that case, x and y coordinates of this point are x and y from the system. So if you want to solve this graphically, you just draw them with GeoGebra and find the intersection point. The x coordinate is x value, the y coordinate is y value. Needless to say that in this case, we have only how many solutions for my system? Only one. But because these are lines, it might happen that when I draw them, they become parallel. It might happen. Yes?
What if A is for example, like a squared number? Is it still a line?
No. If a is a number, x is a square, that's not a line. But we are not discussing about those things. We are only discussing about these systems. So if I have two parallel lines, then what happens? There are no intersection points. And if there are no intersection points, there are no solutions. So this means that a unique solution to the system, no solution. And there is another scenario is that these two lines actually lie on top of each other. So for example, I cannot draw them, but let me see. For example, I mean, in principle, they are exactly the same, but let us try to motivate you what I mean. I mean, these two lines lie on top of each other. In that case, how many intersection points you see? Infinitely many, because every point is both black and blue. So this means that in this case, how many solutions are there? Infinitely many solutions. So these three cases, so it is interesting. Either I have zero solutions, or I have one solution, but nothing in between. Suddenly it jumps to infinitely many solutions. That symbol means infinite. So if I have a system of two linear equations, we have only three possibilities. A unique solution, no solutions at all, or suddenly infinitely many solutions. Okay, so this is what we want to discuss about today. I gave you some examples last time, but let us solve more problems from the book today, okay? So one type of problem is this problem. So this is, I want you to understand these kinds of problems. So determine the constant k so that the equation system you see here, part A, has one and solution, does not have any solutions. So these kinds of problems are different from solving this. Okay, so there is no problem. We don't want to solve the equation. We want to fine tune this k so that for part one of the problem, the system has exactly one solution. And now when it is finished, go to the second part, do the same, go back and find k in a way that the system does not have any solutions. Yeah, so that's the point. There is nothing to solve the problem. So what should I do here? So let me write the system here. So the system is y equals to kx plus 7. And then I have 2y minus 3x plus 2 equals to 0. Let us say that I want to concentrate on solving part 1, in which I want to have this equation, uh, this system has exactly one solution. So what does it mean? It means from geometrical point of view, this should happen. So when does this happen? When the lines are not parallel. Yes? So this is a line whose slope is k and the m value is 7. this is also a line. In this form, still I don't know what k value and what m values are, but I can arrange it in a way that I can read k value and m value from here. So that is at the end a line. That is also a line. In part 1, I want to fine-tune k so that the system is guaranteed to have one solution. So what does it mean? It means that the lines should not be parallel. Yes? And then when the lines are parallel, we had this in Math 1C. When two lines are parallel, if the k values are the same. So if you want not to have them parallel, it means the k values should not be the same. Okay, that's as simple as that, but you have to be able to interpret this. The k value of this is clearly k. In order to find the k value from here, I have to isolate y. So I move 3x and 2 to the other side. Yes? And then I divide by 2, so it becomes 3 over 2 x minus 1, because I have to divide this by 2 and that by 2. So the k value here is k, the k value here is 3 over 2. Okay, I want this to happen. So this means that the lines should not be parallel. So what should I write for answer number 1? The k value of this one and the k value of this one, they should not be equal. That's it. So that is the answer to the first part. So, but you understand it from a geometrical point of view. If k is not equal to 3 over 2, this line and that line are not parallel, so they definitely will intersect. And then if they intersect, how many solutions I will have? I will have only one. So that's it, simple as that. Understandable or not? Okay. Now, forget about part A. For part B, we want to fine-tune k so that there are no solutions. There is no solution for the system. So I have to force the system to have this condition. Two parallel lines but not overlapping lines. Because if I ask you what is the k value of the black line here and what is the k value of the blue line here, the k values are still the same. And here, the k values are still the same. So how can I differentiate between this scenario and that scenario is because of m value. Here, not only the k values are the same, but also m values are the same. But here, k values are the same, m values are not the same. So if you want, I can write them here. So here, I would write k1 is not equal to k2. Here, I write k1 is equal to k2, but what? M1 is not equal to M2. Here, both K's are equal and M's are equal. And that is good to write it in your notebook if you want to take notes. So remember that this is the only thing that we need to understand. For having a unique solution, K values should not be the same. For having no solutions, K values should be the same, M values shouldn't be the same. But for having infinitely many solutions, both k value and m value should be the same. Okay, so for part B, we want not to have any solutions. So I want to have this scenario. So k values should be the same, but m values should not be the same. So in principle, part B, what should I write? I write k values should be the same, so the k value there should be equal to the k value here, and m value there should not be equal to m value there. Yes? But do I need to emphasize here? No, because automatically 7 is not equal to -1. Even though that is not wrong to write, but it is just waste of your energy, yes? I just clean it because it is automatically satisfied, so I'm not worried about that. That's it. So I just want you to know that this problem is simple, but if you don't have an understanding, might be you will be in trouble. You need to understand the problem geometrically. Is that right? Okay. Let us see what other problems are good to check here. So now I want to wait for you so that you can do this one for me. It's a little bit harder because two parameters are involved, both A and B. We want to determine the constants A and B so that the equation system has infinitely many solutions. Okay, so I want to wait for you. These type of questions are different in nature. I want you to understand. Okay, could you solve it?
I think so.
Okay, we want to have infinitely many solutions. So which scenario should happen? The third scenario. So k values should match, the m values should also match. But still, we don't have k values and m values because in both of them, still y is not isolated. So we isolate y in both of them. So I divide by 3, so y becomes this one divided by 3, this one divided by 3. So it becomes a over 3x plus 1. And here you divide by 2, so it becomes 3 over 2x plus b over 2. That's it. Yes? And now that everything is ready, I can read the k values. I want to have this scenario. So k values should be the same. The k value of the first one is a over 3. The k value of the second one is 3 over 2. They have to match. Yes? But the m values should, no, sorry, m values should also match because we want to have infinitely many solutions. The m value from the first one is 1. The m value from the second one is b over 2. And then you solve this. And this is extremely simple because what is a? For a, I have to isolate a, so I multiply everything by 3 to get rid of these 3. So this becomes a, but when I multiply this by 3, what happens? It becomes 9 over 2. So that is 9 over 2. And to here, to isolate b, I multiply everything by 2. So this means 2 is equal to b. So I was able to find both a and b. Is that right? So let me write one from myself here. So the system is 2 minus a times x, and then plus y equals to 1, and then I have ax minus 3y equals to 5. Again, the problem is here. This is the problem in the book. It has 2 unknowns, but I am giving you a system. It has only one unknown, a, but that is the same problem. I want you to fine-tune a so that this system does not have any solutions. Okay, so remember, this is a new type of problem we are working in. I am not asking you to solve the equation, just to solve the system. Find a so that the system does not have any solutions. Okay, what happened? We want to do something that the system does not have any solutions. So which scenario should happen? The middle one. K values should be the same, m values shouldn't be the same. But here, this is a little bit algebraically more involved, not very hard. So here I want to isolate my y, so to be able to read the k value and m value. So if I keep y here and move this factor to the other side, automatically it becomes isolated. Y becomes isolated. So I move this to the other side. It becomes minus 2 minus ax. Yes, you see, there was no sign here. I consider it positive. When I move the whole expression to the other side, it becomes negative of that expression. 1 is already there, so I write it here. So that is my y. Yes? Okay, and then here, I want to isolate y. So what I will do, I will keep minus 3y here. I move ax to the other side. It becomes minus ax. 5 is already there. But then I have to divide by minus 3 to isolate y. So y becomes what? Minus a divided by minus 3, which becomes positive a over 3x. But 5 times 5 divided by minus 3, so it becomes minus 5 over. Okay, so I want to find a in a way that the k values are the same and the m values are not the same. Automatically m values are not the same. Yes, because the m value here is 1, the m value here is minus 5 over 3. So the second condition is automatically fulfilled. So the only thing that I have to know is that I have to put the k values the same. But the k value here is what? minus 2 minus a. The k value there is a over 3. And then I have to solve this equation to answer that. But if I multiply minus sign in, what happens? This becomes positive a, this becomes negative 2, and it becomes a over 3. I prefer to get rid of fractions, so I multiply everything by 3. So this becomes 3a, this becomes minus 6, and that becomes a. So I move a to the other side, 6 to the other side, so 2a becomes 6, and a becomes what? 3. So our prediction is that if a is 3, the system does not have any solutions. Do you want, let us check to be it is true or not. How do we understand it algebraically? Because for example, let us say that you don't know, you don't have access to this method, you want to solve it algebraically. Let me put a minus 3 to see what happens. If a is minus 3, the system, how the system reads, the system becomes minus x, because if a is 3, the system becomes minus x plus y equals to 1. And it is 3x minus 3y is equal to what? Is equal to 5. So what is your guess? If I give you this system to solve, you expect there are no solutions at all, because I myself fine-tuned a in a way that the system does not have any solutions. When I found this a, I put it back in my system, I got this system. My prediction is that if I have done everything right, this system shouldn't have any solutions. But let us innocently start solving it as either using the substitution method or addition method. So here, if you don't mind, let me use addition method. So if I want to use addition method, I concentrate to eliminate one of the variables. I can immediately see that multiplication by 3 is a good idea. So I will multiply the first one by 3. What happens? It becomes minus 3x plus 3y equals to 3. And then I have the second equation without any changes. And then you see what happens when I want to use the addition rule, the addition method to solve it. What happens? Not only this is gone, but unfortunately the second one is also gone. So when I add them, the left-hand side becomes 0, the right-hand side becomes 8, which is nonsense. So it means that if you assume there is a solution, then you have to live with it that 0 is equal to 8. But 0 equals to 8 in mathematics is contradiction. So it means that assuming there is a solution for this gives rise to contradiction, so there are no solutions. So this is what I want you to understand. If I give you the system, you automatically understand there are no solutions, because when you want to solve it, then you get something nonsense. Then it means that this system does not have any solution. So I would say yes, what we calculated at this level was indeed correct, because when I use that a and start solving the system, I realize the system does not have any solutions. But this only tells you only 3. This is the problem is only with 3. If you choose any number except 3, then you will have solutions. Okay. Let me make it a little bit harder and wait for you more. So the question is this. Determine n so that the system does not have any solution. So this is the system I want to write for you. It's a little bit algebraically involved, but the idea is the same. So I have a little bit harder system to work with. So the question is that determine n so that there are no solutions. Yes? This is what we want to solve. I want to wait for you again. Okay, so if you don't mind, if you already know how to solve this problem, you can continue to the next one. But if you don't, if you still have troubles, let me explain this again for you. So the goal is clear. A system of linear equations is given to me. This time I want to fine-tune this parameter n in the problem so that this system has no solutions, and it is on the board. For having no solutions, it means k values should be the same, but the n values should not be the same. So, but the only problem here is that this is a little bit algebraically more involved. I need to be able to find the k values and m values. So I have to isolate y in both of them. So the first equation, I want to isolate y. What should I do? I, for the time being, keep this term here, so it becomes n minus y times y is equal to, I move this to the other side, so it becomes minus n plus 3 x, 7 is already there, but still y is not isolated, so I have to divide by n minus 1. Be careful, when I am dividing by n minus 1, I am already assuming that n is not 1. Because n is 1 means that this is 0, I'm not allowed to divide by 0. But let us have this in the back of our head to see if it matters or not. So y becomes equal to, there are two terms to divide by n minus 1. This term, which is minus n plus 3 divided by n minus 1, but there is an x here, plus 7 divided by n minus 1. This is what you have. So you can immediately read the k value to be this expression and m value to be this expression. But that's it. The second one is of course simpler. So what I do, I move 3x to the other side. My goal is still to isolate y, so it becomes minus 3x plus 4. I divide everything by 2. So y becomes negative 3 over 2. X, 4 divided by 2 is 2. Okay. So I want the system has no solution. So it means that I need to put the k values the same, but I have to make sure that the n values are not the same. Let us see how it is relevant. So the k values should be the same. So k1 should be equal to k2, but m1 should not be equal to m2. Okay? So k1 is equal to k2 means the k value up there must be equal to the k value down there, yes. And then I can eliminate the minus signs, so it becomes n plus 3 over n minus 1 is equal to 3 over 2. And the best way to solve this, remember, this is what you call the butterfly, or whatever the Americans say, that the product of means is equal to the product of extremes. Anyway, this means this number, multiply the whole thing there, is equal to this number multiplied by this. Yes. And then I solve that. It's an extremely simple equation to solve. Because I am going horizontally, I put this arrow. Okay, if I go vertically, I don't need to put the arrow. So this becomes 2n plus 6. And then this becomes 3n minus 3. I move 3n to the left. 2n minus 3n is minus n. I move 6 to the other side, it becomes minus 9. And then n becomes what? 9. Yes? But be careful, even though I found n, still I am not sure that this is indeed true, because I have something to check as well. Might be I am so unlucky that because for that n, the n values are the same. Okay, but I have to check it. So the n value here, if I put n equals to 9, what happens? So the n value there, 7 over n minus 1, should not be equal to the n value here. Okay? So this means that, is this 9 acceptable finally or not?
Yes.
Yes, because if I put 9 here, it becomes 7 over 8, and we know 7 over 8 is not equal to 2. So that answer is acceptable. Yes? So you have to check it out. So n equals to 9 makes the k values the same and makes the n values not the same. So that's acceptable. So if n is 9, then this system has no solutions. Okay? Is that right? Okay. But the next one might be a little bit more complicated, not because it is conceptually harder, but it is algebraically more involved. So I have to do something with the first equation in the system. So what should I do first? This time I want to fine-tune two parameters, 1a, 1b, so that there are infinitely many solutions. So for infinitely many solutions, I have this scenario. So the k values should match, the n values should also match. So I have to adjust the k and n values. For this one, this is extremely simple to isolate y. So let me just do it right away. So I write phi y I move 2x to the right, it becomes negative, and I divide by 5, so y becomes minus 2/5 x plus 12 over 5. So the k value number 1, this is the second equation, so if you don't mind, let us write k value number 2, it's minus 2, and m value number 2 is 12 over 5. So this is very easy.
Oh, but I have a question.
Yes?
About that above your. No.
Hmm?
No.
Okay, is that right?
Yes.
Right. So now, this is the k value and m value for the second line, which was simple. But for the first line, you see I have a mixture of x's. X's are on the left and on the right. Y is also on the left and on the right. My goal is to isolate y on one side and everything else on the other side. That's the goal, because otherwise I cannot read the k value and the m value, yes? So what I do, I will move this 2y to the left, so it becomes 3by minus 2y. And then x is already there. I move 2ax to the left, to the right, sorry. This becomes that. And then there is also a 6 there. Am I right? So I move 2y to the left, I move 2ax to the right. But then I need to factor a y out because I need to know the coefficient of y. So if I factor a y out, this is left. So 3by minus 2y, that's correct. And between these two, I also have to factor x out, because I want to have x in one place to be able to read the coefficient of x to be the k value. So if I pull x out, it becomes 1 minus 2, and then that one is just 6. And now everything is in order. I want to isolate y, so I divide by this, whatever it is. So there are two terms to divide, 1 minus 2a divided by 3b minus 2x, and then I have 6 over 3b minus 2. This is my second line, or to be honest, this is my first line. So what is the first k? K1, what is that? The coefficient of x. It's 1 minus 2a over 3b minus 2. And what is the m value? The m value is this number, which is 6 over 3b minus 2. Yes? But my question is, make it so that this has infinitely many solutions. So that's good. K value should be the same, m value should be the same. And then I can solve a system, a new system. You see, it's a system within another system. But this is different. So you need to understand what you are doing. Don't get confused if it is a system within another system. Yes? So what we do, I would say that K1 should be equal to K2. So this would imply that K1 is here, 1 minus 2a over 3b minus 2. This should be equal to the k value up there, which is minus 2 over 5. Yes? Okay, and let us simplify this again. So I will use this number times that, minus 2 times that. Exactly the same rule. That's a very handy rule. Okay, remember that. So 5 times 1 minus 2a. I put minus for 2. You could put minus for 5. It doesn't matter. So I put minus for 2 and then multiply here. So it becomes minus 2, 3b minus 2. Let us simplify this as much as possible. So this means that I have 5 minus 10a, and then it becomes minus 6b plus 4. Okay, so if you don't mind, let me move this to the other side. So to keep the a and b, my unknowns on one side and the known values on the other side. So this means that I have minus 10a. I move minus 6b to the other side, it becomes positive 6b. I have 4 there, I move 5 there, it becomes minus 1. So that is one equation. That equation comes from the fact that I put k values the same. Yes. Now I have to put the m values the same. You see, I want to have infinitely many solutions. So value m1 should match with m2. So what does this mean? What is m1? m1 is 6 over 3 minus b, sorry, 3b minus 2 should be equal to m2. Up there it's 12 over 5. And the same story, this multiplied by that is equal to this multiplied by that. So this becomes 12 times 3b minus 2 is equal to 5 times 6 is 30. I multiplied 12 in, so it becomes what? 36b minus 24 is equal to 30. Okay, I can solve it, you see. This is a system, but one system, a very simple system, because the second equation depends only on b. You don't need to use addition method, you don't need to use elimination method, because this is just one unknown. When you found b, when you put it back here, you will find your a. So let us solve that one. So this is become 36b equals to 54. b is equal to 54 over 36. And you can simplify this by 18. 36 to 18 2 times. 54 by 18 3 times. So b is 3 over 2. And then I put it back there. So it becomes minus 10a plus 6 times 3 over 2 is equal to minus 1. But 6 and 2 are simplified. It becomes 3. 3 times 3 is 9. So this becomes minus 10a plus 9 is equal to minus 1. I move 9 to the other side. So minus 10a becomes minus 10. And then finally a becomes 1. Yes? So this is a A-level question. But the idea is the same. But the problem is a little bit more involved. Any questions here? So what is the meaning of this? It means that if I go back to my original equation, if I go back to this equation, instead of a, I put 1, and instead of b, I put 3 halves, then I will have a system. If I insist to solve the system, I will suddenly see that there are infinitely many solutions there. Yes? What do you think will happen here? When I started solving this using addition method, both variables disappeared and I got a nonsense statement. But in the case that I have infinitely many solutions, if I want to solve, I will get both of them eliminated, but I will get something true, not something false. In that case, the interpretation is that there are infinitely many solutions, because no matter what x and y is, I get the truth. So it means that every number works. So remember, if you use the elimination algebraically, and then you see one variable is eliminated, the other one is not eliminated, it means that you have one single solution. But if both variables are eliminated, there are two scenarios. Either you get something which is false, then it means that there are no solutions at all, or you get something which is true, then it means that there are infinitely many solutions. This is from algebraic perspective. But from geometrical perspective, you need to work with k-values and m-values, which is easier to understand. Any questions? Okay, so this is more or less what we need to know about the systems. Let us solve some different problems with different flavors now. Any questions here? Understandable? Okay, now let us go and solve some problems. Do you remember we had some now I want to give you a system. Solve the following system for x and y. Following systems for x and y. So let me write the title. Solve for x and y. What do I mean by that? I mean that in your system you have other letters involved. So for example, I want to solve this system. ax plus by is equal to 2a. And I have a squared x minus b squared y equals to a squared plus b squared. Okay. So here, do you remember in Math 1C, we had some similar problems, not for systems, for simple equations. For example, when I wrote mx plus b equals to q, for example, I could ask you to solve for x. It means x is your unknown. I could have asked you to solve for b. If I ask you to solve for b, it means make b isolated. The solution is extremely simple. It becomes q. I move this to the other side. This is solving for b. But if I ask you to solve for x, you have to make x isolated. So you move b to the other side and then divide by m. So this becomes q over m minus b over m. So this, do you remember? We had something like this for one equation in one unknown. But this is more or less the same idea, but with two equations and two unknowns. So I am telling you solve for x and y. It means that even though a and b are not given numbers, but assume that they are numbers, solve for x and y. Yes? Okay, do you have any idea before me telling you what to do? You want to solve for x and y. It means that a and b are assumed to be given numbers.
Baba,
Yes.
if you divide 2a with a, will that become a? Or
Yes.
What?
If you divide 2a by a, it becomes a. But now, let us see how we solve this problem. Any opinion?
2a divided by a into 2. What? Baba, what are you saying? How is 2a divided by a?
So 2a over a
Is that a?
is 2.
Yes, it's 2.
all going to
Yes, it's 2. Why are you saying it's a?
But he said it is 2.
No, I said a.
No, so it's wrong. Yes? Anyway, we don't have anything we do that one now. We want to solve this system. So how should I solve the system?
Isolate y.
Use addition method again. We want to get rid of y. If I want to get rid of y, what should I do? Do you remember you have to do something so when you add them up, the y is gone. It's not hard.
Times the first equation by b.
B, thank you. So I multiply the first equation by b. B is not a number, but you assume that it's a number. It's a given number, okay? So you multiply that. B times a times x is just bax, nothing we can write. But b times y is b squared y. On the right hand side, b times 2 times a is 2ab or 2ba, whatever you want to write, because order doesn't matter. I don't need to do any changes here. So what do? I just copy and paste the same equation. These are more fun because I can test your knowledge not only in systems but also in algebra. Okay? So now I use addition method. So what do you think I will do? I will add them. This will be added to this. Be careful. In the case that I have numbers, I am not. Oh, so what is this one? Sorry, this 2 is here, not there. The 2 is on A. Okay? If I have this a number and a number, I am not in trouble. Say this is 5x and say this is 7x. When I add them, I simply write 12x. But here I have bax, I have a squared x. So what can I do here? I will do the same thing. So I will write x. But here I added 5 to 7, but because 5 plus 7 has a better name 12, I wrote 12 immediately. But in this case, there is nothing that I can do. Only thing that I can do is to write what? ba plus a squared. Yes? So in principle, I wrote bax plus a squared x. In the next step, if you want to, I factored x. Yes? You don't need to do it in 2 steps. Now these 2 are gone, but the right hand side becomes 2ab plus a squared plus b squared. Yes? But now I want to find x. So I divide this by the coefficient to isolate x. But the beautiful of these kinds of problems, I will try to design them in a way that it looks more beautiful than what it looks like now. If you write this from system point of view, you solve the problem correctly. But if you can simplify, Do you remember? This now becomes the lesson that we started in chap 1 very long back. This is a squaring rule, and what can I do here? So a squaring rule is a plus b squared, yes? What can I do for this one?
A plus b squared minus.
No, here, a squared plus ba. What can I do? The only thing I can factorize? Factor a out. So it becomes what? A. This becomes a plus. Yes? So you see, solving the system, one of them, x, is finished here. If you stop here, you will lose because I will ask you to solve and simplify as much as possible. Then what happens now? A plus b squared means a plus b times another a plus b. Okay, so a plus b times another a plus b. You don't need to write so much. I just want to review things. These are factors. These are also factors. So common factors can be simplified. So what's the answer? A plus b over a. But be careful. Am I allowed to simplify this a with that a? No, because this a is not a factor. It's a summand. Summands cannot be simplified. So this is the simplest possible way that I can write my x. But the problem is not finished because I need to find y as well. Okay, so what do you suggest for y? Do you remember? When I found my x, I put it back in one of those equations and find y. You can do that, or if you think that is harder, you can do this the other way around by multiplying by minus a. That's also possible. But let us do this one, because I don't want to confuse you. When you found your x, you go back to one of your equations, probably the simpler one is better, of course, and then try to find the other unknown by isolating it. So for example, I hope that you agree with me, this is a simpler one than that one. So I write a times, it's not hard by the way, x is this expression I found. This is a very good exercise. It's two birds with one stone. First, you need to know how to solve systems. Secondly, you need to know factorization. I mean, 3 birds, 5 birds with one stone, you know. So you have to know a lot of things. And then plus b times y is equal to 2a. Yes? What can I do now here? Yes? A in this and A on that are simplified. So I want to isolate my y, so I keep by here. There is a 2a there. Here, this is left. I move it to the other side. A left to the other side becomes minus a. B left to the move to the other side, it becomes minus b. So by is equal to 2a minus a is a minus b. Yes, and I am looking for y, so I have to isolate my y by dividing by b. Can I simplify this b with that b? No. Very beautiful problem. So I have x and y in terms of a and b. So I want to give you one of these type of questions and wait for you to solve for me, okay? So let us write this one now for you. Okay, I want you to solve this. The topic is the same. You want to solve for x and y. So ax plus by is equal to 2ab, and bx plus ay is equal to a squared plus b squared. I want you to solve for x and y. Okay? Okay, could you solve it? No, let's exactly do what I told you. You want to solve this system. You know that for these systems, addition method is superior. So then you have to decide about one of the variables to get rid of. Which one you want to get rid of first? Let us say y. I want to get rid of y. Here, if I just use the addition method, I will not be able to get rid of it, yes, because this is by, this is ay. They are not opposite to cancel out. So then I have to adjust, you know it from previous studies. So I need to ask myself, what are the suitable numbers Might be here in the previous one, I needed only one suitable number, not number, a parameter, to multiply it by the first one and it worked. But here, just multiplying one of them by something probably is not working. So what should I do? I multiply this by something, I multiply this by something else so that at the end they become opposite. But this is not hard to guess. For example, concentrate here. We decided about to eliminate y first. So I multiply this by a, for example. Then what happens here? It becomes aby. Then I want to make it minus aby to be able to get rid of it. So what should I multiply here?
Minus b.
Minus b. Is that right? So it is not that hard. I multiply this by a. What happens? Ax becomes a squared x. A times b times y is just simply aby. On the right hand side, 2ab multiplied by an extra a becomes 2a squared. Yes? Now I multiply this by minus b. So this one becomes minus b squared x. The next one becomes minus bay. And the next one becomes what? Minus b times that, but also minus b times that. Do you agree? Okay. Now use the addition method. So do you remember what I told you when we add? These two are gone. So my goal is achieved. Yes, my goal was to get rid of one of the variables. But what can I write here? Do you remember?
A minus b.
Yes, a squared minus b squared, and then multiplied by x. Yes? Because if I knew the numbers, I just simply added them. But here I have parameters, so I have to do it in this way. But what happens on the right-hand side? On the right-hand side, I will have 2a squared minus ba squared minus b cubed. Yes? And at least x is found. You get some points up to here. This expression, whatever it is, oh, I made a mistake. There is also a b here. 2a squared b. Yes? So I write whatever I have there. Yes? And then I divide it by a squared minus b squared. Yes? But of course, it is not wrong. X is correct. But it is better to simplify it as much as possible. And then I will, of course, ask it in a way that you have to simplify it. So what do you think we will do here? Do you have any ideas?
Yes.
So what should I do?
ba squared you can subtract that from 2ab.
Yes, these two can be subtracted. Yes, 2a squared b minus ba squared becomes 1ab squared. Because they are similar. So it becomes what? ab squared. Sorry, a squared b. And then I have minus b cubed. Then I have a squared minus b squared. But can I go further? Yes? I can factor a b out. There, yes? So what happens? It becomes a squared minus b squared, yes? Divided by a squared minus b squared. You are right, it's a conjugate rule, but I don't need it. Because whatever this is the same thing. So they are cancelled. So the answer is extremely simple. It's just b. Yes? So x is equal to b. And then when x is equal to b, I take it with me to one of them. It doesn't matter which one. Let me put this, for example, here. So this becomes a times x, which is b, plus by is 2ab. But my goal is to isolate y, so I move this to the other side. So by is 2ab minus ab. But 2ab minus ab has a better name, and that is ab. But now I want to isolate y, so I divide by b. ab over b. Can I simplify it more? Yes. So the answers are extremely nice and simple. So if you do the algebra correctly, when you solve the system, you get x to be b, y to be a. Okay. Any questions? Thank you.